Hi everyone, today we are going to talk about lab number 3 in Power Systems lab. For that lab, what we are going to talk about, phasor representation. For phasor representation, we are going to use RC, and RL circuits, and we are going to connect two different branches, one that has RC and another one that has RL in parallel, and we are going to connect them to the power supply. The purpose of today's lab is to know the relation between the angle of the voltage and the current, and to know how to measure the power factor, how to measure the power, how to measure the voltage and the current using data acquisition system. Let us see the circuit that we are going to use today. We are going to use RC connected in series. R is 600 and XC is equal to 300. And it is connected in parallel with this branch that has 240 ohm resistor and 300 ohm reactance. So I don't have this value. I'm going to use two different resistors to be connected in parallel to get this guy. And those two branches are connected in parallel, and I will connect them to the supply. What I need to do is I need to measure the voltage here. I need to measure the current in this guy, because I would like to measure the power inputs, and also I would like to measure the current here. I would like to measure the voltage across this guy, the current in this guy, and the voltage across this guy, because I would like to measure the total active power. We are going to do that using this resistive load, and this inductive load, and this capacitive load. So I'm going to use only one phase, which is this one. I'm going to use this phase, I'm going to use this phase, and this phase. So this branch is representing a resistance. I have 300, 600, 1200. I need 240, so I'm going to take this on, and this is off. So those, as if those are connected in parallel, and this is open circuit, so I don't have this guy. The total resistance of those will be 240. And this branch is going to be connected in series with this branch that has only 300, so I'm going to open these two, and this guy is on, so I have only 300 ohm reactance. Again, I'm going to connect this guy, which is 600 ohm resistor, in series with this guy, which is capacitive load that has 300 ohms. So this branch will be connected in parallel with this branch, and those two are going to be connected to the power supply. This is what I'm going to do right now. So I'm going to connect this guy to this guy. So this branch is connected in series with that, and I'm going to connect this guy to this guy. So this branch is connected in series with this branch. And I'm going to connect this to this, and I will connect this to this. Now what I have, this branch is connected in parallel with this branch, and this is what I need. And then I will connect this node and this node to the supply, or this node and this node to the supply, because these two are the same and these two are the same. So I need two wires to connect this guy to the supply, and this guy to the supply. Again, I'm going to use AC fixed value, which is 120, because the supply is 120. By doing that, I have already connected my circuits. The next step is to connect my meters. What do I need? I would like to connect a meter here in series to measure the current, and voltmeter to measure the voltage in parallel between these 2 points. So for connecting a meter, I need to use another wire. So this is my wire. I cut it in 2 different points, and I will connect my ammeter between these 2 points. So this is measuring the current. This is the supply current. So the current is going here from the supply to the meter, which is the ammeter, and then going from the ammeter to the resistive loads, or the capacitive or the inductive, based on what you are connecting to. Then I'm going to connect these two to voltmeter in parallel. So this guy and this guy. are going to be connected between this point and this point because I would like to measure the voltage. Then what is the next step? I would like to measure the current inside this branch. So I'm going to connect a meter between these 2 points. So I will connect here 2 wires. And between these 2 points, I'm going to connect a meter to measure the current, going from the resistive load to the inductive load. This guy is measuring the current. At the same time, I would like to measure the voltage between these 2 points. So for measuring the voltage, what I need to use this voltmeter to measure the voltage. It is connected in parallel. So I'm going to connect this guy in parallel with these 2. Right now, I'm measuring the voltage between these 2 points. I'll do the same. I would like to measure the current as well in the capacitive, RC. So I'm going to connect a meter here, and I'm going to connect the voltmeter. What I did, I connected a meter here, and I'm measuring the voltage there. So I'm going to connect here a meter. So this guy is measuring the current going from this resistor to the capacitive element. So this guy is a meter, which is measuring which current? It is measuring this current. Then, last step, I would like to connect what? I would like to connect voltmeter between these 2 points to measure the voltage. So between these 2 points, I will connect voltmeter in parallel. Like what we are seeing here, this my voltmeter. Let me conclude that. E1 is used to measure the voltage coming from the supply, and I1 is measuring the current coming from the supply. And E2 is measuring the voltage across this resistor, which is 240. And I2 is measuring the current in this resistor. And E3 is measuring the voltage across this resistor, which is 600. And I3 is measuring the current inside this resistor. Let us go to the data acquisition system. So for the data acquisition system, I can use it for measuring the current, the voltage, or whatever by clicking on metering, and by clicking on oscilloscope, I can show you the sinusoidal wave for the voltage and the current, and by clicking on phasor analyzer, I can show you the phase shifts between the voltage and the current and the power factor as well. So let us start to click on each one, but I have to turn on my circuit as well. I'm going to do that, but I'm showing you these different things that I'm going to use. So I will turn on my circuit, and then I will refresh this guy. Here, like what you are seeing, this is E1, which is 121. E1 is the voltage coming from the supply, and E2 is the voltage across the first resistor, which is 240, 73.32. And E3 is the voltage across the resistor connected to the capacitive element in series, which is, I believe, 300. So its voltage is 107.5. And these are the currents. This guy is the current going from the supply to the parallel 2 branches, RC and RL. And I2 is measuring the current in RL branch, and I3 is measuring the current in RC branch. Like what you are seeing here, this guy is measuring the power. I can measure the power active or reactive. Here, if I clicked on this guy, it will measure the power, but if I click here on P, it will give me Q. So what I'm reading here is a Q. Click again, it's giving S. This is S. Click again, it's giving back P. So by changing here, whichever the power that you are looking for, here I'm reading P, which is P coming from the source. And here, P and R in the resistance or across the resistance in RL branch. And this guy is P in the resistance in RC branch. Let us go to the oscilloscope that will show me the relation between the voltage and the current. I would like to talk about E1 and I1. So I would like to refresh it, like what you are seeing here. He is telling me channel 1, which is yellow is representing V. This is the supply voltage. And the channel 2 is representing the current. I'm not asking you to draw that, but I'm showing you in this scope as well the relation between the voltage and the current. So this is the input voltage. By the way, I can change the voltage like whatever I want. So if I would like to draw the relation between E2 and, for example, I2, I can do. This is the relation, they are in phase. And I can change here the voltage per division to show it more, and I can change here the voltage per division here, as you are seeing the relation between the voltage and the current in case of RL circuit, in case of the resistance, because I'm measuring the voltage, which is yellow, across the resistor, and I'm showing you the current in RL circuit, like what you are seeing, they are in phase. There is no phase shift between them because you are talking about the voltage and the current in case of a resistor. Let us talk about the power factor. Here, this guy is showing you the power factor. I will refresh it. What do I need? I would like to know the power factor for between I1, so that's why I made it on, and E1, it is on. Here he is telling me like what you are seeing down. The phasor E1 and I1, E1 is equal to 121 and I1 is equal to 0.39, like what you are seeing. These are the same values that I have. And the angle of the voltage is 0 and the angle of the current is negative 21.9. So based on this angle, I can calculate the power factor, which is cosine this angle. This is the end of today's lab. I showed you how to measure the voltage, how to measure the currents, how to measure the power as well, and I showed you how to measure the power factor, and I showed you the relation between the waveform of the voltage and the current in case of the supply, in case of the resistive element, and if you want, you can also see the relation between V and I. In case of capacitive element, there is a phase shift, and in case of inductive element, also there is a phase shift. This is the end of today's lab. I'll see you next week for the next lab, which is talking about transformer. Bye for now.